You are listening to the Neurocareers Doing the Impossible podcast with Dr. K, episode number 27. Dear Neurocareers podcast listeners, today our guest is Asaf Harel, who is a chairman of the board at BrainstormIL. And while working on his PhD in BCIs at the Ben Gurion University of the Negev, Asaf works on building Israel's neurotechnology ecosystem. Part of this ecosystem is neurotech education, and specifically a project called BCI for ALS. It's Israel's first national academic course that offers the chance to explore and develop brain-computer interfaces for people with amyotrophic lateral sclerosis, also called ALS. You already had a chance to learn about the ALS research that is currently being done in one of our previous podcasts with the neurologist Rosella Spataro from Italy. So today you will learn about the neurotech-based project supporting people with ALS in Israel. Thank you very much, Asaf, for your willingness to participate in the Neurocareers podcast. Both I and our listeners appreciate it very much. Can you please introduce yourself and tell our listeners where you are joining us from?
Of course. Milena, thank you so much for inviting me. I think it's so important to have this type of media, either for students or for people who are in academia and also in industry. So it's amazing, I think, the work that you're doing, and I wanted to commend you for that. So I'm currently in Israel at Ben Gurion University of the Negev. It's a rather large university, more to the south of Israel. I'm currently in my fourth year of the PhD, and I really hope to submit my thesis in the coming months. Basically, my research is centered on brain-computer interfaces, specifically looking at markers of visual attention. I'm using different types of BCI paradigms, and I'm really having a good time. I think this is such an exciting field, and it has huge potential. So it really got me hooked on the topic, and I hope that in the future we'll have a large, vibrant ecosystem to continue that work even outside of academia.
Thank you very much for your introduction. And can you tell a little bit more? What was your path getting into the field of neurotechnologies, and what inspired you to get into this field?
Of course. So I began my academia looking into studying psychology. I was always very intrigued by the feeling of consciousness, of awareness. And in my career before academia, I focused a lot on attention, and specifically how attention can be overloaded, and when that goes wrong, what happens. So when I began my psychology education, to me it was very interesting, but it always seemed to be a little too abstract. I'm much more of a data-oriented person, and I really missed talking in numbers, thinking in numbers or in matrices, and how you can manipulate them into extracting some useful information. So that was always a missing piece for me. So when I finished my undergraduate studies, I searched for something that combined more of my passion, and I found a program. It was a relatively new program at Ben Gurion University. And I remember coming to the university and speaking with the graduate program mentor, and I asked him, how do I choose what to do? And he said, what you have to do is you have to walk around, go around the labs, and speak to the different PIs and ask them, what are they researching? And I said, okay, great. So tell me what you're researching. And he said, oh, I'm doing brain-computer interfaces. And I said, whoa, hold on. Tell me a little bit about that. And we ended up talking for maybe an hour and a half just about different types of BCI paradigms. And I said, I don't need to talk to other researchers. I found my spot. And luckily, he was willing, and he had a place for a graduate student. And from then on, I found my calling for the next 4 years. So that's kind of my academic history and how I went into the field.
Thank you so much. And I think you showcased a very important point for those students who are trying to figure out what do they want to do, where do they want to specialize. It's so important to really go and speak and see what people are doing, because what we can imagine or read might not be reality. So when you went and you heard about this, you already knew, yes, that's it.
Mhm.
And I know different examples like this. And even my nephew, who didn't know where to specialize in chemistry, he went, he saw organic chemistry lab, and that was it. That was the love from the first sight. And he already finished his PhD and did postdoc and so on and so forth. So that is very important. I just want to make this point very clear to our listeners, to our students, that go and speak and see it for yourself where it is done. So thank you for pointing this out. And you are an active participant in BrainstormIL network. So what does it do? Can you tell our listeners more about this?
Yeah, of course. So during my first years in the PhD, I began to think ahead and to look at what opportunities are available for those who finish their PhD. I mean, I think a common experience for students in the field is what I like to call the Friday night dinner with family. So you're sitting at the table. In Israel, it's very common to have Friday night family dinners, and there's always, the parents or the some family member who ask, okay, so it's amazing that you're studying brain sciences, but what do you do with it, right? Where do you make the money? How can you get a salary and so on? And I never had a very good answer for that. It seemed like the industry opportunities for people with a PhD in computational neuroscience were very narrow, right? You could utilize a lot of the tools that you use to study the brain, for instance, machine learning and data extraction and data science and so on. You could utilize that, in almost any vertical. You could go to any type of high-tech company and do that. But then you miss out on the basic or the key component that brought you in the first place to study that. There's no neuro in what you do. And that was always something which really bothered me. At first, my PI told me, listen, why don't you start some kind of book club or a journal club and get some people who are also interested in neurotechnology and maybe brain interfaces, and just get like a weekly or a monthly meeting going on. And at first, I wasn't sure there was enough value for that, but I started running those meetings, and it was amazing. So many people came. I think at the first meeting about BCI, about 100 people walked into the room. I immediately felt like, okay, there's a lot of interest around this topic. It's exciting. It's interesting. A lot of people are thinking about this, and this was before Neuralink or before all the big media headlines. So we started really running these monthly programs, and after a few months, we said, okay, let's maybe think about this in a broader concept. And we set up a hackathon, a large hackathon in our university, and we invited students from all over the country, and a lot came. This was a very short, I would say, type of event, maybe like 24 or maybe 48 hours. But a lot of students came. I remember walking around the tables of the groups working, and I asked the doctorate students there, no, why don't you maybe start your own type of journal club or community in your university? And maybe you could link up and hold some events together and so on. And at first, people were hesitant, like me. They said, oh, we don't have time. The thesis is so demanding, and I'm not sure what type of value I'll get from this. But after a while, I think people started coming onto the idea that it's a lot of fun. It's very interesting. It's a social community. So you get to meet a lot of like-minded people who share your passion for the same topic. And that happened a few times. We even started holding some national events and attracted a lot more people. And then we decided, okay, since it's a little more than just a community, we decided to actually go and start a nonprofit organization with the goals of actually impacting the Israeli ecosystem. So combining, on the one hand, all the social characteristics of having a community, along with the need to promote an ecosystem so that the industry will grow and there'll be more startups and more companies that are working specifically in the neuro field. And that's what Brainstorm is all about. We're trying to look at the industry and the academia and also the clinical verticals in Israel and see how we can advance all these together to just promote a stronger, more vibrant ecosystem. That was a long long description.
Yeah, but very nice description, and it tells our listeners a lot. First of all, that something that seems maybe not a high value, yes, when you were just starting those meetings, might become something very, very powerful and start impacting the whole country, really. Yes, so don't underestimate things that might seem at the beginning very simple and maybe not that significant. So this is number one. And number two, and now my question is, what is now your answer to those people whom you were meeting at Friday's dinner about possibilities to get employed after you started developing that infrastructure? Did the number of places and possibilities increase with this?
Yeah. So now I'm obviously much more passionate about our work. So first of all, I'm happy to say that one of our projects was mapping out the ecosystem. Because in order to have some sort of impact, you want to have some key parameters that you want to monitor, right? Or some indicators. So we asked ourselves, first of all, how many companies are working in Israel? So this was a lengthy process of reaching out, utilizing all of our different types of networks and using databases and so on to understand how many companies in Israel are of any size, right? From startups to large enterprises, how many companies are working in this field? And I was really surprised to find that there's about 140 different companies in Israel, specifically looking at the neurotech field. And you could argue, what is defined as neurotech and what isn't. And it's a broad subject. We decided to use a relatively broad umbrella term for neurotechnologies. But I'm happy to say that, at least now, and by the way, this database is completely public and free, and we've posted it on our site in a very useful kind of tool. So now, for any student or anybody who wants to go into the field and doesn't know who to reach out to or what type of companies are there and what kind of technology segments each company is working in, now it's all available and you can go and look up whichever company and understand what they're doing. And through the Brainstorm network, actually engage with that company and maybe send some like a CV or look for a job offering and so on. So in that term, that's, I think, a pretty good contribution to the ecosystem. But asking whether we've physically or actually impacted the ecosystem, have we contributed to substantial growth? That's a more difficult question. From all of our events, we've helped create 2 or 3 companies, which is, on the one hand, not so many. On the other hand, you'd say, but this is a completely non-profit volunteer group run by mainly students. So I'm happy to say that it's an impact I'm proud of, but it did open up our appetite to do more, to think about what are the challenges for graduate students or even undergraduate students who want to start their company in the field. What are the challenges and how can we help them overcome them and maybe even streamline the process or help smooth out the process to bring them to a point where this group is viable in terms of raising the necessary funds or reaching out to the relevant mentors and so on. So it's a work in progress, but I think we're on a good track.
Yes, and I think that is a significant impact and opening and helping already several companies and now creating possibilities for more. Basically, you open the door for that process to start happening. Thank you. And can you tell how does this ecosystem, Israel's neurotech ecosystem, how does it look like at the moment? What are the major players in the industry?
Yeah, so Israel, I think, has some strengths, and especially when it comes to the academia. I think there are some well-known Israeli universities who are well-known in the neuroscience field in terms of impact of PIs and in terms of their ability to transition from academia to industry. And Israel is, I think, very strong in terms of innovation overall. we have completely disproportionate numbers of startups per capita here. So I was talking about academia being a major player in the ecosystem, but you can't neglect the industry sector and also obviously the clinical sector. And the dynamic relationship between the three different pillars is really what creates a robust ecosystem. So I think in terms of large industry players, there are not that many. There was one company called El Minda, which was relatively large, but has since then faded. We have a strong company working in the DBS sector, deep brain stimulation sector, which is actually doing pretty well. But I would say there aren't that many like Neuralink or Synchron or BlackRock or these large, well-funded companies that are working out of Israel, unfortunately. In terms of the clinical sector, I think Israel is also pretty strong. I could say that perhaps a company that's called Insight Tech, and they produce a focused ultrasound, non-invasive medical procedure to treat glioblastoma, for instance. And so they have very, amazing successes. So the juxtaposition of the clinical and industry sector have some success or have some models of companies who have succeeded, but it's still, I would say, too little. And the last factor, I think, would be the regulatory part, right? So the government has a very strong position to play in terms of different types of financial motivation. And I think they're really understanding that, and they're starting to invest in this field specifically. And I think it's a good proponent of what's going to happen. I think in the next 5 to 10 years, we will see a lot more companies coming out of Israel.
Mm-hmm. Mm-hmm. Yeah, and with that, I have a question. You already mentioned that there are many startups, but there are no major companies like Neuralink and BlackRock. In terms of that, it shows that some components already are well established. Yes, and there is innovation, there are startups, but some components are still missing. So to get already to that stage, what are possible developments that need to happen, in your opinion, that can already help companies to progress to that next level?
Mm-hmm. Well, I think there's two problems, I would say. One of them is solvable, and the other is not. The solvable problem is all the process of tech transfer from academia to industry. And for that to work, that's acting as a type of bottleneck right now, because the different financial incentives are not really well aligned for entrepreneurs who are just finishing their graduate studies. It's difficult to bring out your idea from research to industry without losing too much equity, I would say, to the different tech transfer organizations. And this is a matter of policy, because once I think mainly the universities understand that it's in their interest to have as many startups try, most of them will fail, but if you have as many of them try, and you streamline that process by not requiring too much equity from the company or from the relevant IP, that will really help create more companies. The second problem, which is not solvable, is just the market size. Israel is a small country, and it doesn't really matter how innovative your technology is, or how many people it could impact from a clinical perspective. It's still just a drop in the ocean. So most companies use Israel as a type of beta site to validate their algorithm, their technology, their business plan, or maybe not even business plan, but their algorithm and technology, and then immediately go and look at the broader markets, whether that's in Asia or the EU or the US. And that's why I think Israel is not going to double or triple its size anytime soon. So that'll be an issue, I think, for a while.
Mm-hmm, mm-hmm. Thank you for your answers. And now I would like to go more into the field of academia, to talk about the course that we mentioned at the beginning of our podcast. Maybe we can start with a little broader overview about what are the main academic neurotech programs in Israel that currently exist. Maybe you can provide this brief overview.
Yeah, I'm not that well acquainted with all the different programs in the universities. I can say that in traditional academia, traditional neuroscience academia in Israel is a bit old-fashioned. and the term that thinking about applicative uses and moving into industry is still regarded in some places as not as highly regarded, I would say. But there are new programs that are coming up in different universities which do look at entrepreneurship and do look at combinations of neuroscience and engineering, neuroscience and data science, which really, bring out a new prospect for that. I know that in Bar-Ilan University, they have a very good program for undergrads that combines engineering and neuroscience, and also nanotechnology and neuroscience, which I think is amazing. Here in Ben Gurion, obviously, we're very much trying to promote the transition to industry, but there are places where it's still frowned upon. So that's in terms of different kinds of programs. It really matters to which university you're going. Some are very well, some will motivate you for that, and some will motivate you to continue your work in academia.
Yeah. Yeah, absolutely, and good that variety exists, and but also good that there are new programs that are being developed, and that help with that transition into industry and applicability of the research. And now, can you tell our listeners about this BCI for ALS program?
Mm-hmm.
What does it look like? How was it developed? Where even the idea came from to organize this program?
Yeah. I'd just say it's an amazing program, and I say this a completely subjective, interpretation, but it's an emotional program. It's we get students. You know what? I'll start from the beginning. I was very lucky to present a poster in the Graz BCI Society event, which was amazing to see all the different people working in the field. This was when relatively early in my career. And I was also able to witness there a Cybathlon event, specifically the BCI track. And Cybathlon, for those who are not aware, is an amazing competition which began, I think, in Zurich a few years ago. And up until COVID, they held a yearly event which really brought different types of assistive technologies to the forefront, whether it's using different types of electrostimulation to promote muscle activity and different types of wheelchair accessibility and robotic prosthesis. Really amazing technologies. And one of the tracks was also a BCI track. So you would get people who are completely immobile for different clinical reasons, and they would compete on a virtual game using a BCI. And I remember seeing this event in Graz, and I was just completely blown away. I thought, well, we have to bring this to Israel as well. I would love to set up this type of competition. So I came back after the conference, and I was able to relay my experiences to a friend, also a PhD student sitting next to me, and he was also immediately hooked. And we kind of spent the next year planning out exactly how this would happen. And we thought about going specifically to the ALS population because it seemed like they are the type of people who would most benefit from this type of technology, especially since being completely locked in is such a horrible or demoralizing event. We thought immediately that we have to go and see how we can combine these two things, this competitive drive on the one hand, and a population that would most benefit from this type of technology. So we spent the next year planning out exactly how this is going to happen, and we made some trips around the universities in Israel, and we were able to collaborate with a few PIs, and we began just a year-long course for students, and this was at first thought to be only for advanced students, for graduate student levels. And we spent the first 2 semesters teaching the students what is a BCI, how to develop BCI, what are the different theoretical concepts. We also supplied them with some open source hardware, and this is a good spot to say thank you to OpenBCI. Through their discovery program, they granted us some of their systems so we can start working, which was amazing. So we provided the students with the hardware, the code base, and the theoretical concepts underlying BCI. And that was the first semester. And the second semester, we teamed up with a nonprofit organization called Isra ALS. It's actually the nonprofit group which really helps all the different ALS patients in Israel. And with them, we found specific ALS mentors that joined the program as well. And we would team up the groups of 3 or 4 students with an ALS mentor, and they would customize the BCI to that specific mentor. in terms of the relevant use cases and in terms of their specific individual brain activity, so that in terms of hardware and software, it would be completely customized to that ALS patient. So that was more than 2.5 years ago. Since then, this last semester, we opened our third cycle. Every time, for me at least, it's an incredible experience looking at how motivated the students are, how unbelievably engaged the mentors, the ALS mentors are, and it's it's an amazing experience.
Yes, thank you for this introduction. So, the inspiration that you got from Cybathlon and then how you were able to implement it, can you tell a little bit more about the patients you are working with? What type of patients are they? How do you find them? How do they participate in a project? What it takes from them to be a participant, and maybe how many people you already worked with over the course of several years?
Yeah. So we look for very specific people who are, in terms of their disease progression, are able to talk, who are social and communicative in terms of how they feel and how they can speak openly about their disease, and that really want to be engaged in this type of project. So when you try to find out you look at the entire population in Israel who have ALS, it's about 600 people, give or take, per year. So if you look at the geographical distribution and all the personal characteristics that you're looking for, we get around 20 or so ALS patients who are viable candidates in terms of being a good fit for the program. And one of the most important characteristics that we found that's prevalent across all of them is their personal strength in terms of personality. As you know, to be proficient in a brain-computer interface, you have to do a lot of training. You have to do a lot of trials of imagining a left or right movement if it's a motor imagery paradigm, or looking at different types of visual flickering stimulus if it's more of a visual paradigm, and the same thing for if it's a P300. So you have to really invest a lot of time and effort into that. I mean, and sometimes investing a lot of mental effort is much more difficult than investing physical effort, especially if it's tedious and it's long. But we're always so amazed at how these people understand that what they're doing is not just for themselves, it's for other ALS patients as well. And they're willing to just put in the time and train the algorithm over and over again. So that's how we find them, and that's how we work with them. I think up until now, we've worked with 16 different mentors. Unfortunately, since the beginning of the program and until now, some have already passed away. As you know, the progression can be very uncertain, and you never know how long it'll last. And that really exerts a psychological stress, obviously on the caretakers, the families, and the patients themselves, but also on the students. So a student, you can imagine, a 20-year-old or 21-year-old student who's never worked with a clinical population and has never experienced all the detrimental effects of working with people with disease. So their impact is also something that we're looking at. So we provide a lot of emotional preparation tools, and we make sure that the students understand that they have to fit their expectations. They're not going to be able to cure their ALS mentor. And they in all likelihood, they won't be able to provide an amazing communication tool. It may be very rudimentary. It may be very, very simple. It could give a yes or no question or answer, and that would be a very good outcome. So we spend a lot of time setting good expectations with the students and obviously with the mentors, and the first meeting between the two. So every time a group of students meet a mentor, it's always with a mediation by one of the national team members in order to get over the initial icebreaker and so on. All of these different experiences, I would say, are completely new for anybody working in academia. I mean, if you're thinking about teaching linear algebra, you never think about the psychological aspects. You never think about how that would affect the same person in the long term in those terms. So that's something we never thought about when we started out. but it's an amazing lesson for life.
Yeah, absolutely. And I remember from your talk, when I first listened to you talking about this project, really was very appreciative of your initiative to include psychologists on your team as well for debriefing and helping students with that psychological challenges that they are going through. So I think it is very, very helpful. And how do you see this involvement of psychologists maybe transforming or helping students to go through the project? Do you see an impact of this work?
I think in all the different cycles in our history up until now, there were maybe one or two students who we thought could use a little more help in that term. But otherwise, I think setting good expectations at the beginning and letting the students understand what it is that they're coming into is really, really important, and it really provides or it counteracts, I would say, that all the negative effects of the first meeting of being shocked by looking at someone who is not moving, who's breathing through a tube and is communicating through a computer screen with you. And so I would say, on the first hand, you need to prepare yourself, the students, and the mentors. And on the other hand, you have to have a safety net prepared for them, and you need them to know that there is a safety net. So if there's any student that is not really sure if they need help or not, we immediately set up a meeting and just get people to talk about whatever it is that comes up. And by the way, everybody is volunteering for this. The psychologists and so on, they're all volunteers. So I think just having that safety net is, you can't underestimate the importance, but it's hard for me to say, how effective or how ineffective. I think we're a bit too early in the process to really get, a good feeling about that.
Yeah, absolutely. I know that you are referring to patients with ALS as mentors.
Mm-hmm.
It's a very interesting way to refer to patients. And can you explain a little bit the meaning behind that? Why did you choose this particular name for patients you are working with?
Of course. So we defined this very early on in the process, even before we started the first cycle. And this was for many reasons, but mainly because we looked at the mentors as an integral part of the team, because they would define the characteristics of the project. For instance, we worked with one mentor who was completely mobile. He moved around. It was not an issue for him, but he had a lot of difficulty talking. So for him, what he wanted from the group was not a wheelchair or a type of communication on screen and so on. He just wanted to be able to play with his grandson in the playground. So the team constructed a little toy car for him and like a steering wheel. And on the steering wheels would be different types of SSVP LEDs that would flicker, and he would control the toy car using the steering wheel, but not with moving it, by just like looking at the different LED lights. And that was in our mind, or along with him, we decided, right now you're completely, you're mobile and so on, and everything is relatively easy. But we want, to start working with a BCI, and just in case in the future you're going to need it. So I think that's an example of looking at the specific requirements or requests of the mentor and implementing them in a way that we also wanted to combine a BCI, which might be used for communication later on. And I think if you looked at the mentor as anything but mentors, if we looked at them as patients or as customers or any other type of population, this would really ruin the important dynamic that we were aiming for. Because if the mentor is an integral part of the group, then everybody's more motivated to be very engaged. So that's why it was really important for us to define them as mentors and nothing else.
Yes, it definitely demonstrates even the care and the relationships, yes, with these patients and looking at them as mentors. And that is a very important point that you made. and also interesting from the academic course perspective that each of the approaches you take with the neurotech, it's unique to every single patient. So it's not that you just have one BCI for communication that is built by the end of the course. So it's a unique solution for each individual mentor.
Exactly. Of course, there were mentors who used a more traditional BCI, whether it's a motor imagery or even an audio P300. But once again, we really try to customize each paradigm to what the team feels would most benefit the mentor. And that has to be along with the mentor to understand his or her personal needs and requirements and so on.
Yeah. And what other examples of the neurotech that you built to address certain specific needs of mentors? Maybe you can provide several more examples.
Well, one mentor which I had the privilege to be with the team that met him, he would move on a wheelchair, but rather independently. But he couldn't speak, and every time he wanted to grab someone's attention, he would need to make like a sound, like a sound with moving some muscles in his throat. And immediately, a family member came by and was looking at his lips, and that's how he communicated. So we thought, maybe we could give him something which could change instead of the movement with his throat. He could use some type of BCI component, and this would be a very simple, just one classifier. And so the team really went about working that, and they created like a really, really simple, like a doorbell sound, so that every time he wanted some attention just for a minute, he could, instead of straining his throat muscles, he could just imagine a movement, and that would ping. So I think that's also an example of using a very, very simple hardware, right? So this really not very innovative in terms of technology or engineering, but understanding the specific mentor's use case and applying this roughly the same technique to bring that forward. I think other types of examples are more traditional in terms of having some stimulus on screen. Mostly we do different types of spellers or keyboards, and each team really tries to improve the different types of accuracy levels or add more dimensions or classes and so on. Yeah, that's that. I think that encompasses most of them.
Yeah, thank you. And what do you see is the impact of this project is on the community of patients and mentors, yes, and also their families?
We were very honored that ALS, the nonprofit organization, and their yearly event, they hold a yearly gala event for fundraising. They showcased this project and recorded a movie, which had us interviewing, and also the mentors and the students. So this was very emotional, and in front of hundreds of people, they showed this movie, and some mentors also spoke about the importance of this. So I think definitely for the mentors who participate, for them, I think they get a lot of value, and not just from the results, not from the BCI itself, but from participating with the students in an effort to provide some future tool which they understand might not serve themselves, but will serve others who may need it. For them, I think that's the value that they get, and I think that for the family members and caretakers, we really start to have very amicable, very friendly relations, and because they see groups of students coming to the house and talking and laughing with the mentor and thinking about it, and for this type of weird hat. Uh, so for them, it's a good experience as well, and I think they're happy that from a social perspective and from also inspirational perspective, their loved one, their mentor, is also participating in this type of effort. In terms of the larger community, I don't know. It's difficult to say. I think that the program is becoming more well known, whether in academia or in different type of non-profit organizations. But I think it's up to us to continue putting out the message and raising more awareness for this program.
Yeah, absolutely. But definitely you can see already the impact, and it will be growing as the program also grows, and the more students probably are joining it in the future.
Yeah.
What do you hear already from students? What value do they feel they get from this program? What is the feedback they provide?
That's easy. Most of them are completely. I mean, it's obviously a first type of experience of this type. I mean, there's no other academic course which matches this. Not to belittle other academia courses, it's just that this. I mean, during your academic studies, you almost never work on something which is completely undefined, so abstract, and includes real people who have real needs. I would say maybe some social degrees have such programs, maybe medicine as well. But in terms of engineering and neuroscience, I think this is completely new. I think all of the students immediately say, this is, I've never experienced such a thing. This is amazing. And almost all the students want to participate and to provide from their experience to the next cycle and so on. And we're thinking about maybe creating a type of graduate community from the program, right? So we could have like a network of people who have already finished the course and can help and maybe provide more connections to the industry. Maybe there's a company that wants to sponsor a certain type of program and so on. But that's all, down the road. We're really focused on just getting the students as much help as they can to develop the BCIs for the mentors, to provide them with the knowledge and the tools that they need.
Yeah. Were the main challenges for you building this course? How did you overcome those challenges? And what are the challenges that you still need to overcome that you see are maybe hampering the development of this project?
Yeah, well, the challenges are that it's very time intensive. You need to have people who are dedicated to meeting with the different student teams. So we have teaching assistants in each university, and we have a principal investigator who's leading the course in each university, but it still requires a lot of input by the national team because TAs usually are not so experienced as well. I mean, we hope that each TA will be a graduate from the program, but they still need more input and more assistance from us. Every time there's a hardware issue or a software issue, Windows upgraded something and everything just breaks down. So you need to continuously maintain and help the TAs and also keep the PIs engaged as well. That's not a trivial matter. Also, the PIs, that they're very time constrained and it's difficult to get them engaged and get them, spending the time. I would say that the most difficult thing really is and it will continue to be difficult as time goes on, is to just finding the time to keep the system going, to keep the student enrollments going, to keep this, posting on social media and so on, being in touch between the different universities, the different TAs, and along with the Israelis nonprofit organization, getting all the different players still working together is a continuous challenge. We hope also that one day somebody will replace us, right? So that the program will continue to work with us out of the picture as well. So you have to find the right people for that, and you have to train them and so on. So that's a continuous challenge.
Yeah. This project, as you mentioned, is not a project just of one university, is a national project. Can you tell more what universities are participating, how all this network look like that is involved in the project?
Mm-hmm. So early on, we had very lofty ambitions. We thought maybe we're creating a new Israeli brain or BCI society. But once you get down to the details, you understand that it's so much work. You have to be really focused on getting a specific hardware, working with a specific software, and the students around that, and combined with the ALS mentor, right? So you need to get the basic building blocks working first, and hopefully there'll be later on or some higher order type of community which forms or just emerges from this activity. So the idea was to have as many universities participating as possible. So we had a university from Haifa University and the Technion, which are both northern universities. We had Tel Aviv and the Hebrew University in Jerusalem, and there's Ben Gurion University in the south where I am. And each year we had different types of not all of them participated all the time. Each cycle we have different groups working together, and that really is determined by the amount of time that we spend on enrolling students and engaging with PIs and finding the right TAs to continue the work. But I think overall, the fact that we have universities who are asking us to open the course with them, that's a really good sign for us. That means that we're doing something which is of importance, and people see the value and they want to do it as well. We're just the time constraint is very, very difficult.
Yeah, absolutely. How long does it take to go through one cycle?
Each cycle is 1 year. We start September, an academic year, and we finish it roughly July, I would say, maybe June. Each group has to go through the entire process, understanding the basic concepts, linking them together, and recording data from themselves, and then meeting the mentor and starting to record from her or him, and then customizing that specific setup to the mentor's needs. And then we finish the cycle with like a big meeting. The mentors usually come via Zoom or some type of virtual meeting, and each group really showcases the process that they had, say a few words about their experience, and then we go on. And that's always a very fun and emotional event because the mentors usually also try to speak, those who can speak via Zoom, and those who can't perhaps prepare some written statements or something, and you read it out to the group. So it's always very rewarding.
Yeah. How many students are usually participating in one cycle, and how many mentors do they work with?
In our case, n equals 3. There's 3 cycles, so it's difficult to get a mean and median. But I think the minimum would be 10 students from a university. So that would be 2 teams working per university. Last year we had, I think, 50 or 60 students. This year, I think we have 20 or 25. In each year, we try to find the right students, right? So I'm not sure we can interview all of them, but we do have some rigorous standards for joining the course. The students have to be very aware what they're signing up to, and to have the time to put in the effort to continue to complete the entire course. We don't want any people to drop out. So in the beginning, there's usually some movement, but then they continue on for the entire year.
Mm-hmm. Mm-hmm. And what became possible with this course? What wasn't possible before? Even in terms of mentors, in terms of student learning, anything that you see that became possible?
Well, I think one really important outcome is that we have all the students, past and present, on the same platform. We communicate with everyone by Slack, which is a just easy to use forum. And that's also being facilitated by the Brainstorm network. So everybody who's really interested in neurotechnology is on the same Slack workspace, and they can talk about different types of topics that interest them and ask questions. And we actually put it in as a requirement. So if you're a student from Tel Aviv and you finish, the pre-processing module from your theoretical concepts, you're obligated to post a recording of your own EEG before and after the pre-processing pipeline, and you have to post it on Slack so that everyone can see. So students from Ben Gurion and Tel Aviv and Jerusalem and so on. And then we try to get discussions going. Why do you see that artifact over there? Or is it even an artifact? Maybe it's real brain data. And how do you know? And how can you provide different tools for analysis? So getting like a more national forum, like a discussion forum available, that's something that I think wasn't there before. It circles back to what we talked about in the beginning of impact on the entire ecosystem. So for people to know that there's a platform that's available for them, free of charge, to debate, discuss, and maybe ask for help in Hebrew on a certain type of topic, it's possible for them. And I hope that that'll continue to grow.
Yeah. And what are your future plans?
That's a big question. My future plans is to submit my PhD thesis. Once that's over, I don't know. I think the industry sector is a little more attractive to me right now, but that may change. Call me again in a few months, and maybe I'll know.
Now, about the future of neurotech infrastructure that you are helping to build in Israel, how do you see it in, let's say, 20 years from now? Or how do you want it to be? Yes, 20 years from now.
Well, 20 years is such a long time. I have no idea what's going to be in 20 years, but I think maybe in 5 years, because 5 years I think is more tangible. And I would say that, from the academia standpoint, a student that comes into neuroscience will have a much better understanding of what their future looks like, either in academia or in industry. And they will have a lot of opportunities to, through a network, through different types of tools, to participate in hackathons and workshops, in different types of more personal oriented events that will help them to integrate into industry, or maybe even create something from themselves. So one of our initiatives, and this is circling back to Brainstorm, one of our initiatives is to create different types of maker spaces or R&D centers, hubs in each university, so that each of our communities can go there to these places and just tinker around, play with different types of open source hardware, such as OpenBCI or others, and have available tools that they can use to maybe try and take their concepts from research and use them in a more applicative manner. And from then on, different entrepreneurship programs that can help them advance that into a company. So this is something that I really hope will be much easier for students to do in the future. And this is it's not a dream. I think it's very, very plausible. We have one such hub working in Ben Gurion. We're opening one or two more, I think, in the coming years. And so I hope that'll happen.
Thank you. One more question from what you just said. I think students might have better chances of replying to a question at the Friday dinner about what they will be doing after they graduate from this type of program.
Yeah, exactly. Nobody will ask them because it will be so obvious.
It will be obvious. Yes, that's good. Good outcome to strive for. And from that perspective, the name of our podcast is Neurocareers Doing the Impossible. And you are a demonstration of doing things that were not possible before, but are becoming possible and will be even more possible in the future. So what would be your advice for those students or people who are getting into industry and want to do something that is currently not possible? So what does it take to make impossible possible?
Oh, wow. I would say two important things. First of all, stop thinking about it as impossible. Think about it as possible. You just need to find the right way. And the second thing is, you can't do it alone. I was so privileged to have two colleagues who are each bringing in really valuable pieces of information and knowledge and expertise and work and effort into the program. And this is by no means something that I've done alone. And this is true for BCI for ALS, and this is true for Brainstorm, and probably for and for my doctorate thesis as well. You need to do this along with more people. If you want to go far, you have to go together. And this is, I think, BCI for ALS and Brainstorm are an amazing examples of that. So I would say find like-minded people who share your passion for whatever it is that you want to do, and believe that it's possible. You just need to think about, what's the best way to achieve it.
Yeah, that's beautiful. Thank you so much. We talk a lot about in our podcast about this power of collaboration. So really big projects take an effort from a number of like-minded people to complete. What helps you to have successful collaboration with people? What character traits are necessary, or maybe skills that are necessary to really continue, not only to start, but continue successful collaboration over time?
I think the first thing is perseverance or persistence. You need to think about it always as a long game. For people who are doing their PhD, this is maybe obvious because you from the start you're in for at least a 4-year program, so it's going to be a long marathon, not a quick sprint. The same thing I think for any type of endeavor that's really worthwhile doing. You have to persevere. You have to keep working at it. Then the second thing is, and this is a bit counterfactual to academia. I mean, in academia, you're always taught to think critically. And this is such an important concept in science, and it's very, very good. It's a very robust way to do good science. But when it comes to relationships, and when it comes to working along with people, especially in very demanding, high effort jobs, you have to remain critical, but also be very compassionate towards your people working along with you. And even though you may be a bit slightly wrong about something, or not exactly well aligned with the latest terminology, you need to think about what's important and what's not so important. And the not so important, you have to release and think about the collaboration itself as more important than whatever task it is that you're currently discussing or debating. So having compassion to those people that you're working with, and seeing the actual relationship as more important than perhaps the specific task or objective, I think is a very important part in achieving good collaboration.
Thank you. Thank you. I think that's very valuable advice. Often we forget about relationships and more thinking about tasks, but for collaboration, that is very important to remember about the relationship itself. Now, if students are listening to us right now and they start getting interested maybe in the future in neurotech industry, where would you suggest them to start to explore this topic? What would be your recommendation?
Well, happily, since the field has made a lot of media waves since Neuralink really started, but a lot before, really, if you get into it. So any Google search will find you a lot of results about neurotechnology. But if you want more credible sources, I would start looking at different universities and what types of programs they are offering in the field. It's also a good place to talk about a community called Neurotech X, which is doing amazing work, bringing together the neurotech community around the world. This is not a geographical community, but a really worldwide network. And I could never accurately say how important their value is to the system. So I would look, at different types of communities and maybe try to join such a community. Look at whatever local meetings, workshops, hackathons. Try to join virtual events. There's Neuromatch Academy, for instance, which is also doing an amazing job teaching and broadcasting this knowledge. As long as you have a stable internet connection, you can be very easily integrated into the neurotech space.
Yeah, absolutely. Thank you so much. And if students or any listeners that are listening to us want to get in touch with you or to learn about the programs you are participating, about what you do, where and how they can do that?
Of course. So we have a site for the community. It's called BrainstormIL.com. And you can email us or even me directly through info@BrainstormIL.com. And everyone is welcome to ask questions. We try to reply in a good time. But I encourage everyone to try and contact and get to know as much information.
Thank you so much, Asaf. At the end of this podcast, I want to wish you all possible success in your PhD thesis, and of course to continue doing the amazing work you are already doing, and with the developing infrastructure of neurotech and helping ALS patients and helping students to get knowledge and practical skills. That is absolutely amazing. Thank you so much for doing all this. It's really very impactful. So, and this example, I think, can set a beautiful example to many other countries and programs. I think that's why I really wanted to highlight the work that you are doing. So thank you so much. Thank you.
Thank you, Milena, and thanks again for producing this podcast. I think it's very important as well.